My name is Flash Isaac, and I'm a teacher from the future. When I was much younger, I saw thousands and thousands of people fail Jamb and unable to gain admission. This made me travel in time. Now I am back with the Flashlearners Jamb app and a series on YouTube tagged 120 Days to Jamb. My mission is to help you blast Jamb and as well get justice for everyone who Jamb has served breakfast. This is episode number 32 of the 120 Days to Jamb Chemistry with Flash Isaac. And I am happy to tell you that in this episode, we are dealing with electrolysis. Electrolysis is a big boy topic in chemistry. It is a redox reaction where electrical energy is converted to chemical energy. The beauty of chemistry is that every topic tends to relate. For example, we dealt with acid, bases, and salts. And in the previous episode under redox reaction, we were able to see that generally acids are oxidizing agents. And we saw other things related to acids, bases, and salts. Now, this is a next topic after redox reaction. We've seen that electrolysis is a redox process. A process where oxidation and reduction are taking place simultaneously. The aim is to convert electrical energy to chemical energy. The electrical wires in your house, for example, this is a copper wire, pure copper. This is a lead, soldering lead. Now, in wiring, we also use aluminium for wiring. If you look at aluminium wires, they are white. And this is the color of copper. Since copper is more expensive than aluminium wires, some persons or some companies, they will do an aluminium wire, they will spray copper on it. So if you scratch even anytime you see a wire that claims to be copper or a changeover that claims to be copper, look for something to scratch it. If you scratch and you don't see anything white, then it is a pure copper. Copper, aluminium, all these metals, they are conductors. They allow electricity to pass through them easily. Now, they conduct via electrons. And why these guys are conducting, they don't mate in the process. No, they conduct in their solid state. Copper, aluminium, silver, these are very good conductors. In fact, silver is better than copper in terms of conductivity. However, you cannot afford silver. If you use silver to wire your house, at night, people will come and cut it and sell. That being said, there are substances or compounds that only conduct when they are in molten state or in solution. Molten state or in solution. And these guys are compounds. Meanwhile, conductors are elements. I've given you the features of conductors. Now, giving you the features of this guy, you should be able to compare and contrast with conductors. Now, these guys, they conduct when they are in molten state or in solution. Molten state means they are not in solid state, they've melted. Solution means when they are inside water, when they dissolve in water. All these guys are referred to as electrolytes. While conductors are elements, electrolytes are compounds. They conduct via ions. Electrolysis is simply splitting by means of direct current. It is a phenomenon where a direct current is passed through electrolyte and it splits into its component ions. Electrolysis is the passage of a direct current through a compound that is in molten state or in solution with decomposition taking place at the electrode. Now, if you pass direct current through this compound, it will decompose. Therefore, it begins to conduct when in molten state or in solution. And the compounds or the substances that conduct electricity only when they are in molten state or only when they are in solution are referred to as electrolytes. Now let's see some examples of electrolytes and let's see electrochemical cell, because electrochemical cell is where electrolysis actually takes place. Electrolytes are grouped into strong electrolytes and weak electrolytes. Just like strong acids, strong electrolytes dey dissociate completely in solution. Meanwhile, the weak ones dey don't dissociate or ionize completely. Examples of strong electrolytes are hydrogen chloride or hydrochloric acid, HNO3, NaOH, KOH, NaCl, H2SO4, K2SO4, NH4Cl. These are strong electrolytes. And weak electrolytes are organic acids, methanoic acid, ethanoic acid, ammonia, water, and amines. These are weak electrolytes. And examples of non-electrolytes are benzene, ethanol, sugar, urea, cane sugar, and tetrachloromethane. These guys are non-electrolytes. And looking at these electrolytes, they can be in molten state or in solution. Molten state means they've melted, but there is no presence of water. Only them just melted. In solution means they are in water. Now, anytime an electrolyte is in solution, it shows that water is present, and water will also ionize. When water ionizes H2O, it will give us H plus and OH minus. These are ions present in water. So let's look at something. If we have sodium chloride, molten sodium chloride, the ions present in molten sodium chloride are sodium ion and chlorine ion. That's all. How about sodium chloride solution? In sodium chloride solution, the ions present are sodium ion, chlorine ion, H plus, and OH minus, because it is in solution. Solution, when the substance is in solution, there will be presence of hydrogen ion and hydroxy ion. Now, for copper 2 sulfate solution, that is Cu, copper sulfate is CuSO4. For this guy in solution, the ions present are copper ion Cu2 plus and sulfate ion SO4 2 minus. So, copper 2 sulfate solution, we have Cu2 plus, we have SO4 2 minus, we have hydrogen ion H plus, and we have hydroxy ion since it is in solution. For molten copper 2 sulfate, there is no presence of water because it is not in solution. So the ions present are Cu2 plus and SO4 2 minus. For KOH solution, caustic potash, potassium hydroxide, the ions present are potassium ion K plus, hydroxy ion OH minus. Then in solution, we have hydrogen ion plus OH ion. What does that tell you? In KOH solution, there will be presence of excess OH minus, presence of excess hydroxy, which means this compound or this solution will be so basic because we have a lot of hydroxy ion. For molten KOH, the ions present are basically potassium ion and hydroxy ion, molten. For H2SO4 solution, we have hydrogen ion is present, H plus, SO4 2 minus is present, another hydrogen ion H plus is present from water, then OH minus is also present. These are electrolytes and their ions, or how they dissociate in solution. These are the steps in electrolysis. Let's look at the typical electrolytic cell. It has the electrolytes, which are compounds that decompose or conduct electricity when in molten state or when they are in solution. It has the direct current source. Of course, electrolysis is splitting by means of direct current. So there is a presence of DC source. This is one difference between electrolytic cell an electrochemical cell, which we shall be looking at in one of the episodes. For electrochemical cell, there is no DC source. Now, we have the anode and cathode. The anode and cathodes are the electrodes. Current go in and out via the electrodes. As you can see, the electrodes, they allow current to go in and they allow current to go out. And decomposition or deposition takes place in the electrode. For an electrolytic cell, we have two types of electrode. We have the positive electrode, which is referred to as anode, and we have the negative electrode, which is referred to as the cathode. Now, this is not so for electrochemical cell. For electrochemical cell, the positive electrode is cathode and the negative electrode is anode. Electrochemical cell is reverse of electrolytic cell. Don't worry, we shall get to that as well. But here, the anode is the positive electrode and the cathode is the negative electrode. The process of electrolysis is this. 1. Direct current is passed through the electrode. You see, this is the direction of flow of current. And as a rule of thumb, the flow of electron is opposite to the flow of current. If current is flowing this way, electron is flowing this way. They are always inverse. When you pass direct current from the DC source, it goes from the electrode to the electrolyte. Now, as the current gets to the electrolyte, it decomposes. That is electrolysis, splitting by means of direct current. Let's take this electrolyte to be molten sodium chloride. Molten sodium chloride. Let's call this NaCl, molten. Immediately the current passes through the electrodes and gets to the electrolyte, it will decompose. And decomposition means it will break into its component ion. And like I explained so far, for molten sodium chloride, these are the ions present. So immediately it gets here, this guy will decompose to form Na plus and Cl minus. This is a positive ion and this is a negative ion. In electrolysis or electrolytic cell, positive ions are referred to as cations. Negative ions are referred to as anions. Anode is positive and cathode is negative. It will be true that negative ions will move to the anode. So anions will come to the anode because unlike charges attract, like charges repel. Since cations are positive ion, the cations will migrate to the cathode. This is positive ion, negative ion. Negative to positive, positive to negative. In essence, since sodium ion is a positive ion, it will migrate to the cathode. We have Na plus here. Since chlorine minus is a negative ion, it will migrate to the anode. We have Cl minus here. So, in electrolysis, the one that is deposited is the same thing as the one that is discharged. At the cathode, sodium ion is discharged or deposited. At the anode, chlorine ion is discharged or deposited. That is basically what happens. After here, something called cryo happens. Cryo. What is cryo? This is a shortcut. This one means cathode reduction, anode oxidation. So, after the migration of ions, in the cathode, reduction will take place. In the anode, oxidation will take place. What is oxidation? Oxidation is loss of electron, while reduction is gain of electron. Since we have Na plus in the cathode, if sodium ion gains electron, what happens? It obviously becomes sodium atom. So at the end, this changes to sodium atom. This is chlorine ion. If chlorine ion gets electron, at the end, will give us chlorine molecule Cl2, and everyone is happy. This is basically Na plus loses electron minus electron to give us Na. And the anode is basically Cl minus plus electron gains electron. So 2 electrons actually at the end to give us Cl2 atom. But this is not the problem I told you about. The problem is this. How about a situation where we are dealing with sodium chloride solution? We know that for sodium chloride solution, these are not only the ions. We will have H plus and OH minus. These are all the ions present in sodium chloride solution because it is in water. If we have something like this, look at what will happen. At the anode, anions will move to the anode, negative ions. We will have Cl minus here and we will have OH minus here. At the cathode, positive ions will migrate, which means we'll have Na plus here and we'll have H plus here. Now that we have more than one ion, which of them will be preferentially discharged or deposited? Because only one of them will be discharged. Which of them? So there are 3 rules to know the one that will be preferentially discharged or deposited. 1. Position in the electrochemical series. The higher the position of an ion in the electrochemical series, the lesser it will be deposited. The lower the position in the electrochemical series, the easier it is to be deposited. 2. Concentration. The higher the concentration, the easier it is to be deposited. The lower the concentration, the harder it is to be deposited. And 3. Nature of electrodes. If these electrodes, they don't react, they are inert, they will not affect the reaction or the electrolysis. But if the electrodes are taking part in the electrolysis, then they can fall in love with certain ions. We shall look at that. To know the one that will be discharged or the one that will be deposited, we use 3 rules. There are 3 rules for preferential discharge. 1. The position in the electrochemical series. This is the electrochemical series of cations, positive ions, and this is electrochemical series of anions, negative ions. Electrochemical series is simply the activity series. Now, in terms of electropositivity, potassium is the most electropositive. As you can see here, it is at the top of the series. In terms of electronegativity, fluorine is the most electronegative non-metal. If you take a look at this series, you will see this arrow going up. From bottom to the top, there is increasing electropositivity. That implies that potassium is more electropositive than gold. Magnesium ion is more electropositive than hydrogen ion as it goes up. Secondly, you see an arrow going down. That implies that from potassium ion downwards, there is increase in preferential discharge. So, the ones at the bottom of the series will be preferentially discharged compared to the ones at the top. In this case, you see increase in electronegativity. That means fluorine ion is more electronegative than hydroxy ion. It is more electronegative than chlorine ion. In fact, in this case, most times OH minus will likely be preferentially discharged unless for one thing, which I will explain soon. In terms of preferential discharge, the lower it is in the series, the easier it is for it to be discharged. There is a shortcut for electrochemical series of cations and shortcut for electrochemical series of anions. For this one, you say that popular scientists can make a zoo in thin, low, humid country more satisfactory good. Popular potassium, scientists sodium Can, calcium. Make, magnesium. A, aluminium. Zu, zinc. In, iron. Tin. Low, lead. Humid, hydrogen. Country, copper. More, mercury. Satisfactory, silver. Good, gold, aurum. So you see, popular scientists can make a zoo in thin, low, humid country. More satisfactory, good. For non-metals or for anions, this is the shortcut. Francis showed no conscience breaking Irenaeus' heart. Francis, fluorine, showed SO4 ions, no, NO3. Showed no conscience, chlorine, breaking, bromine, Irenaeus, iodine, heart, OH, hydroxy. So, Francis showed no conscience breaking Irenaeus' heart in terms of preferential discharge. Now, let's apply that to this question. If we are given sodium chloride solution, these are the ions in the solution. So, at the anode, we have Cl- and OH-. Now, let's compare. OH- is lower than Cl- in the series. So, at the anode, OH- will be preferentially discharged, or it will be deposited. At the cathode, we have sodium ion and hydrogen ion. Sodium ion is right at the top and hydrogen ion is here. What does that mean? Hydrogen ion will be preferentially discharged at the cathode. So, we have OH here and we have H+ here. And remember cryo. At the cathode, reduction will take place. What is reduction? Reduction is gain of electron. At the anode, oxidation will take place. What is oxidation? Loss of electron. At the anode, oxidation takes place. The OH- will be oxidized to water, and oxidation is gain of electrons. At the cathode, reduction will take place. What is reduction? Gain of electrons. So, hydrogen ion gains electron to give us hydrogen molecule. This is basically what will happen in the end. Now, look at something. How about we are told to look for, or we are told to solve for electrolysis of brine? Electrolysis of brine. Electrolysis of brine is simply electrolysis of concentrated sodium chloride. Concentrated sodium chloride is referred to as brine, which means we have more of sodium chloride than water. That is a concentrated solution. So the first factor that affects discharge is position in electrochemical series. The second factor is concentration. For concentrated sodium chloride, this is exactly what will happen. These are the ions present. Because there is water, concentrated doesn't mean it is molten. It means there is a little water. So in the water, there will be hydrogen ion and hydroxy ion. Then sodium chloride, sodium ion and chlorine ion. Now, which one will be preferentially discharged? At the anode, we have chlorine ion and hydroxy ion. Now, this is chlorine ion, this is hydroxy ion. Chlorine ion is higher than hydroxy ion in the electrochemical series. In fact, since chlorine ion is higher, hydroxy ion is supposed to be preferentially discharged. But this will not happen. Why? Concentration will take a part. Since this is a concentrated sodium chloride, instead of hydroxy ion to be discharged, it will not be discharged. Chlorine ion will be discharged instead. So the one that is concentrated will be preferentially discharged. So when you are told concentrated, then concentration will take place. Cl- will be discharged. How about at the cathode? We have sodium ion and hydrogen ion. This is sodium ion, this is hydrogen ion. Now, which one is higher in the series? It is sodium ion. Which one will be preferentially discharged? Hydrogen ion. But since this is a concentrated solution, will sodium ion be preferentially discharged instead? No. Concentration only works when the ions are closer in the series. If we have ions made up of, let's say, hydrogen ion and copper ion, or hydrogen ion and iron, hydrogen and zinc, if they are close in the series, the one that is more concentrated will be discharged. But hydrogen and sodium, they are far apart. Concentration will not play a role. Hydrogen will still be preferentially discharged. Then at the cathode, reduction takes place. Gain of electron. This will probably end up in hydrogen gas. This one will end up in chlorine molecule. That is basically it. We have another factor that affects preferential discharge. It is the nature of the electrode. There are a few situations where the nature of electrodes affect. Generally, if you are given electrolysis questions, we use position in the series and concentration to look for the one that will be preferentially discharged. If the ions are far apart, concentration will not take effect. Like sodium and hydrogen, or potassium and hydrogen, concentration will not affect the discharge. However, chlorine ion and hydroxy ion, they are close. Concentration will affect the discharge. But for hydroxy ion and this surface ion, they are far apart to an extent. Concentration may likely not affect the discharge of them. But this guy and this guy, this guy and this guy, since they are close apart, the one that is more concentrated is discharged or deposited. Now there are situations where the nature of electrode takes effect. Look at this. If you have electrolysis of sodium chloride solution, as you can see here, obviously we know that the negative ions will migrate to the anode, giving us Cl minus and OH minus here. And we know that the positive ions will migrate to the cathode, giving us Na plus and H plus. Look at this. Sodium is higher than hydrogen in the electrochemical series. Far higher. They are not mates. So normally, hydrogen will be discharged or deposited. But what happens? If you use mercury electrode, if here is mercury, instead of hydrogen to be discharged or deposited, sodium will be discharged, sodium ion. This is because mercury loves sodium so much. Mercury has affinity for sodium. As such, it will drag sodium to itself to form sodium amalgam. Which means, if you are told to look for electrolysis of sodium chloride, and they tell you that mercury is the electrode, sodium will be attracted to mercury. So sodium ion will be discharged instead of hydrogen ion because of the nature of electrodes. Otherwise, things work normally. Now, if you do the electrolysis of silver salts using silver electrode, the silver electrodes will generally attract the silver salts. So these are two major conditions Jamb expects you to take note of when it comes to nature of electrodes. If you don't hear mercury electrode or silver electrodes, go with what we've been doing before: concentration and the position in electrochemical series. Ladies and gentlemen, electrolysis. This brings us to the end of this episode. Get your Flashlearners Jamb app and begin to play with questions. In the next episode, we shall look at Faraday's laws, then we answer questions under Faraday's law. Then we look at one or two questions under electrolysis as well. So that we act at the end of electrolysis and Faraday's law. See you in that episode.